Hey everyone, welcome back to the Python backend series. So far, we've built a Flask API that can send and receive data, but right now that data is temporary. It disappears whenever we stop the server. Today, we're going to be fixing that by connecting our API to a real SQL or SQLite database, and no installs needed. It's actually built into Python. So let's talk a little bit about what we'll be learning, how to create and connect to a SQLite database, how to store product data permanently so no more resets, and how to build a products API using actual SQL. So before we get into coding, the first thing I'd actually recommend doing is to wherever your folder is, so mine's just in a Python folder here, we have our app. I'd actually recommend putting this within its own folder. Maybe we'll call this one Python backend example. And let's go ahead and put that app in its own folder. This way, when we're adding the database and things like that, or any other README files, or even for GitHub, etc., storing it here is going to make it so much easier for ourselves in the future. Just a nice little organizational tip. You will notice Visual Studio Code gets mad at us, rightfully so. We took away the project that we had open. I'm just going to go ahead and drag and drop this back on in, and we can see that our file is still good to go. When we're talking about the coding part now, let's go ahead and import our SQL. So we can do that by typing in SQLite 3. As we're coding and going through this, I might call it SQLite, but just know it is SQLite. So we don't need to do a pip install for this one. We're just importing it through Python directly. And let's go ahead and establish our database connection. What we're actually going to be doing is last time we kind of moved our products to this global variable that we can use so we can actually see those changes in real time. Let's go ahead and delete that. And we're going to create a function to actually grab the database connection. So we can call this one get_db connection. If you want to call it something else, feel free to do so. But that's what I'm going to be naming mine. We're then going to establish a con for the connection, and this is going to equal the SQLite3.connect. And then we're going to connect this within the parameters to what we want to call our database, and we're going to be using this to actually create our database file. So for us, we've been calling it products. I'm going to do the .db, and this is going to create if it doesn't exist or open up that SQL database file. We'll then add the con.row_factory to equal the SQLite3.row. And this is going to allow us to actually use the column names, like if we had row name, row price, and then we'll go ahead and return the connection. So return con. So essentially this function connects to the products.db file, which is a file that gets created automatically when we write to it the first time. And if the file already exists, we're going to then connect to it. No need to create it ahead of time manually. So next we're going to be initializing the schema, and this is going to set up our products table just like the list we used before, but now we're going to be persisting it. So after this connection here, we're going to create another @app.route. And this time we're going to be going to the /init. So this is kind of our initialization page instead. We'll then add a comma, and then we're going to add our methods. It's going to equal those square brackets. Oh, not the squiggly braces, the square brackets of a string of get. So that is kind of get messages that we've been sending out. Then we'll create a definition or a function, I guess, to initialize the DB. Add our colon, nothing within the parameters here. We're going to reference our con, so our connection again, and it's going to equal our function we just created of the getDB connection, empty parameters. And then we're going to add our con.execute, and we're going to be adding a little bit of code, and I'll do my best to kind of explain it as we go. So within the brackets, I'm going to add 3 quotation marks. I'm going to hit return a couple times and add those 3 quotation marks again. This is going to allow us to make a multi-line string, which is going to be really helpful because we're adding a lot of text here. While we're coding, it's going to be in caps, and then when we're referencing any values, they're going to be in the same capitalization. So for example, we're going to do create table if not exists in all caps. And then we're going to reference our products. So essentially what this does, it says, hey database, make a table called products, but first check to make sure it doesn't already exist so we don't accidentally overwrite it and throw an error. Next, we're going to kind of be defining what columns our table will have. So we're going to add a bracket here, and I'm just going to press return a couple times just so it's a little bit easier to kind of read. We're going to reference our ID, right? I don't know how I ended up opening the kind of console there. Anyways, so we're going to have our ID, and if we look at our JSON here, we had the ID, name, and price. So for our ID, we're going to say in all caps, integer primary key auto increment, which is one word, then add a comma. So the ID, and this is the column name, the integer, well, it's an integer type. We have numbers without decimals, so we have ID 1, 2, 3, etc. The primary key, make sure that each row has a unique identifier. No two rows can have the same ID. Auto increment means we don't have to manually specify this number. Every time we add something, it's going to increment by 1, 2, 3, 4, 5, and so on. Next, we had the name value. And for this one, we're going to say text, not null, and then comma. So name, which is that product's name, headphones, etc. Text stores that text data. Not null basically says this field must always have a value. You can't insert a product without a name. And then we also had the price. It was a real, not null. Price, name of the product. Real, this type is used for floating point numbers. So any numbers with a decimal. So price like $9.99, $10.99. Not null. Just like with the name, every single product needs to have a price. Okay, and outside of these brackets here, we're going to do our con.commit, empty brackets, and our con.close. Essentially, the commit is going to save changes to the database, and the close is going to close the connection in order to free up resources. And then we'll go ahead and return our JSONify. Add our brackets, and then add our squiggly brackets. We'll establish a message, and then the message will have a string, which will say database, init complete. Or you can say initialized, up to you. Okay, next, let's go ahead and add products to the database. So if we actually go down here, we should have already done that with post, absolutely. And we don't have to make too many changes here, but because we're using the database, we're gonna be adjusting it slightly. So here where we have our products method post, our data is totally fine. Now just remember, it's going to expect JSON data with the name and price fields request within that body when we send it through Postman or if we do curl. So let's go ahead and also include a name, which is going to be that data.get of name. We'll do the exact same thing for our price, data.get. This time the price value. Next, we're going to establish that connection. So which is going to be our get_db connection, empty brackets. So that's going to establish our database connection. Okay, next we're going to establish a cursor, which is going to equal our con.cursor with empty brackets. And then we're going to reference our cursor once more with a cursor.execute. And within here, we're going to be doing something similar where we had our execute above here. So we're going to add a string value, and in all caps, we're going to say insert into, and then we're going to reference our products in all lowercase. Then within the brackets, we're going to include the name, price. Then we'll say values. And from here, we're going to have a question mark, comma, question mark. Outside of the string, we're then going to add more brackets, and we'll say name, comma, price. Essentially, this is going to allow us to insert a new product into the products table. We'll then go ahead and commit this. So we'll add our con.commit, empty brackets. Next, we need to handle the new ID. So we'll do new_ID, which will equal the cursor.last row ID. So we're always adding things kind of to the bottom, and it's going to get the ID of the newly inserted product. Then we'll do our con.close. And for our new product, we just need to make a couple updates. Instead of kind of incrementing the products here, since we've already handled that, we'll just have this reference the new ID. And for the name and price, we're just going to reference the name and the price. We no longer need the products append new product because we're not storing that in a list in this file. It's now in the database, and we should be good to just keep our JSONify message here. All right, and let's go ahead and also update our get products here, which should be right above our post. So we're going to establish our connection again over that database, and then we're going to establish our rows, which is going to equal our con.execute. And within the brackets, we're going to have select space asterisk, so that kind of star symbol from products. And then we're going to go ahead and fetch everything. So outside the brackets, we're going to do dot fetch all with empty brackets, and then we can go ahead and close that connection again. Another change we have to make is within our return. We're instead going to kind of return that dictionary and kind of all those rows, and we're going to loop through them so we get all of them. We're going to add our square brackets, and we're going to say dict, add a bracket for the row, then for row in rows, which should loop through all of those different rows within our program. Essentially, we're converting the database rows into a list of dictionaries to send as JSON. And just as a note here in our post, because I forgot to mention it, the question marks actually prevent SQL injection. This is called a parameterized query. So we should be pretty much good to go. And I'm going to show you, we kind of have this little funky thing within our code, and I'm going to show you a way to fix that after we do the test, just so you can understand what it is we would be fixing. So you can choose to either test in Postman or in curl. I'm going to do Postman. I feel like it's pretty easy. So I'm going to open up our little Postman tab here, or you can use the separate app. We'll do a new HTTP request. And we're going to be doing a post because I actually want to add some headphones permanently to our database. Let's go ahead and change this to post, and let's do the products. It should be saved. If not, you can totally just grab it. Oh, and we should definitely also run our server. That'd be a good idea. Anyways, you can copy the URL there. We will be sending it to the products. All right, so we want to post something. We're going to do body raw JSON, just like we did before. And what was the format? We needed a name and a price. So we'll add our squiggly brackets. We'll say name. We did headphones last time. What's another thing? We could just do, let's do microphone. And our comma. We also need a price. For this one, it's a number value. So let's do 125.99. Remember, I told you we might have something we need to fix, because right now, if we send it, you might be getting an error that's like error 500 or 400. And this is because you might need to initialize the database. Because I test and do things ahead of time of this video, I wasn't replicating this error, but it's something that came up. So let's actually visit the URL real quick. The way you can fix that, if you are getting that weird error, is to actually go to the URL and do the /init. And you'll see that the database initialization has been completed. Again, because I kind of, work through these tutorials before I record them. I didn't get that error, but if you are getting it, head on over to the localhost URL and do /init. Otherwise, if you get the kind of 200 or 201, you should be good to go. We can see that it has been created. And similarly, if we actually go to this URL, and if we do want to verify that we can see the products, let's go ahead and check that out. We have the microphone just to continue testing and the persistence. Hop back into Visual Studio Code. And this time, instead of the microphone, maybe we can do headphones. And we'll put the price as something different. Maybe they're $100.99. Let's go ahead and send it. 201 created. Let's go ahead and refresh our products. And now we have the ID for headphones. Perfect. Another way to kind of fix that weird error that we were talking about, let's head back into our Python project here. We're going to scroll all the way down to our if name main, and instead we can actually automatically initialize the database whenever we run our Flask app. So what we can do is we can say with app.app_context, our empty brackets and a colon here, and we're going to go ahead and initialize the DB, the empty brackets there. So now when we run that project, it should just actually initialize that database. So you can either do it by going to that URL and initializing it, or you can add this little bit of extra code. We can kind of see, and we even restarted the server here. If we go ahead and refresh that, we can see that our headphones and microphones are still persistent, which is really great. All right, let's go ahead and instead try a get request here. So we're going to request the products. So let's go ahead and send it. If you look at the tab here, we have the raw and pretty. I don't know what pretty does. Looks the same. I don't know, maybe the preview. Oh, the preview, blinding. Okay, anyways, we can see our JSON response here with the ID headphones. Oh, I guess I have 2 headphones in there. Oops. Wait, how many headphones do I have? But yeah, we can see our products. I would also just, for any of those kind of like server responses, right? You can always feel free to pop on the browser here and go to the products. It's a good thing that these have different IDs, right? Because in the case I do have multiple headphones, they might have different prices, right? They have the different IDs in order to kind of separate them, which is great. We can send as many of these requests as we want and kind of keep building up our database. So for this one, we'll add a name, and maybe we can do like the microfiber cloth. Oh, make sure it's a string value. We'll add our comma, and then we also need the price. And let's say that's only $10.99. We can go ahead and send that over. 201 created, refresh. microfiber cloth. Perfect. Look at that. And yeah, in between server sessions, right, we're no longer losing kind of that database. We're now storing everything within that SQLite database. It's something that's persistent. So we can use those post requests, we can use those get requests, and we can make an interesting backend for a web app, mobile application, whatever you really want to use this for. We've now really explored how we can use the SQLite database for this. Right, and for my fellow Mac users out there, and potentially Windows users, you may have went to your backend example folder and been like, wait, where's my database? And I'm even looking for the hidden files here, and I can't find it. Well, just in case, it might have actually went to where Visual Studio Code automatically kind of puts the files that you create. So for me, it's under my users. You also do a quick Spotlight search or Windows search. So it's products.db. And we can scroll down. We can see that it's under other, and we've modified it. So for me, I went under my Macintosh HD, under users. And again, it's also kind of hidden here. I had to scroll down a little bit. And we can see we have our products.db. I'm going to go ahead and drag this onto my desktop. And we'll put it in our Python folder just so we always know where it is. So backend example, and let's go ahead and add it there. Your experience, it might have added it to the folder. If you do want to kind of find it, you might have to do a quick little search, or it might be under your kind of user files there. And this way we can use it for zipping, sharing, or pushing it to GitHub. If you do want to open up the file, I would actually suggest downloading a free software. I personally use the DB browser for SQLite, link in the description below. What we can do is once it's installed, we can open it up and we can actually see the products here. We have like the different names, IDs, prices, etc. We can browse the data so we can see the headphones, microphones, and all those different things we were saving today. And after we've moved our file, we're just going to update our database connection just to make sure, triple check it's using the correct database, especially if it did end up putting it. If you moved it into the folder and you can't see anything, or you want to double check that you're using the correct database, I'm going to show you a little trick how to do that. So in our database connection, we're going to import OS for the operating system. Then we're going to establish our directory for where the file is, and we can have that be a base directory. I'm just going to call it base dir, which is going to be our os.path.dir name, so directory name. We're going to reference our os.path.abs path, and then we're going to reference where our file is, so the _file _. Then we're going to establish that path, so the db _ path is probably a good name for it. And we can call this the os.path.join. We're going to reference the base directory we just created above. And then we're going to reference the file name of products.db so we can find that exact one. And now within the connect, we're going to update this to instead just be that db path. So this is basically going to say, hey, I want you to use the file from which we're booting from, in like this directory essentially. And then the actual file I want you to reference within that directory is the products.db. And we're just going to connect to that path. So now when we run our application, we go to our web browser. Let's go ahead and add the products. We can see that we've connected to our database once again. So just in case it's not in the folder, or you want to double check that it's using the specific one, that's how you can handle that case. So you now have a Flask API that talks to a real database. Your data is stored across sessions, your API is dynamic, and we're one step closer to a full backend. In the next video, we're going to be exploring how we can grab specific data, right? We're going to be looking at even adding authentication with our API. So things like how to securely store user data with hash passwords, how to register and log in users, etc. Hope you enjoyed the video. If you did, leave a like or a comment, subscribe for more Python videos, and I hope you're enjoying the series. Otherwise, dream big, code bigger, and we'll see you in the next one.